Okay. This is going to be the information about this truss. What its truss name is, how many of them are there, what the slope is, spacing, span, things like that, how many plies, and then it gives you in the left and right heel what their overhang heel height is, overhang type, what all of its options are. Okay. The description kind of really doesn't do anything. But anything you do is only going to change this truss. When you're in truss space, and you have a truss mark in there, okay?
Can I ask you a quick question? So,
Yes.
this job that we were looking at has an interesting soffit. Is that something? Let me see if I can pull up the.
Okay.
Is that something that we could pre-build into the truss? The soffit here?
Yeah, you can use those soffit commands to do that. The details, sorry. Or yeah.
Okay.
Oh, house on a roof truss.
Oh yeah.
Yeah. See the truss details?
Yeah.
But you'll have to do them in here one truss at a time.
Is there a way to have this applied to all the trusses in a steel engine?
No. Unfortunately not.
Okay, I was just curious. But this is how we
the only thing you could do possibly in there would be to you could create some like ceiling planes in that, and you could create it that way and have it brought over. But bringing them in here is probably going to be easier for you to do, because all you got to do is say, here, I want to put this on both overhangs. There it is.
Okay.
What the soffit length is, if there's a gap between, more than likely you're going to put a gap between in and the wall so they can set them in.
Right.
What his bearing gap would be between the vertical and the wall. You'll want to put something. You'll want to put some kind of distance in there so it, if you put 0, they're going to have to wedge them in. But if you put like a 1/4 inch, they got a 1/2 inch to play with to put it in the building.
Yeah. I've always tried to do 0 tolerance before, and it never works.
Yeah, it's a great idea, but
like if they have dense glass or sheetrock or plywood,
if something's off by just a little bit, now somebody's cutting something.
All right, but that's good to know. We were just curious if we needed to modify that.
Oh yeah, no, that's the way to do it.
Okay.
Now you could do it at a truss on a. You do that in the truss. Job. Oh, hang on.
Can you do that in one of these settings?
Oh, hang on. Give me a second here just to check this. You could apply that to the entire job. So, but unless there's a truss in there, it gets. So
like,
when you go to bring them back in, we'll there's an option that when you bring them in, there's some changes. You may want to make some settings changes, but I'll get into that in a second. There should be an option to pick that detail when you create the trusses to apply it to everything. So if you go to Yeah. So if you've got them all in and go, hey, I want to do this, what you can do is there's a section, if you go set up job and then go to truss details, pick one.
Right, okay.
Yeah, it's just pick one. I'll show you how we do it. And then click OK,
Just for the sake of example.
just for example. Now, there's a button up here that says global changes. It doesn't apply until you do this global change thing. There's a button that looks like the Earth on your toolbar.
Found it.
Click on it. In order for this to work, for that, you'll click on changes in truss details. And then you'll have, do you want it to only to be the selected trusses or all the trusses?
Okay, so for example, we may not want
There's some you may not want to put it on.
like we might only want it on one side for these.
Exactly. So you may want to go to those and do it a little bit differently.
So like for these short ones here, will it be smart enough to say like don't modify this side because it's not an overhang?
Well, you would think it would be, but
You never know.
I'm not going to guarantee that it will. So go ahead and pick that truck. Just go ahead and click OK. So if you select them all, that gives you the ability to pick the trusses you want to assign it to.
Got it.
So if you just pick one of them, but it doesn't do anything until you tell it to apply to one.
Oh, I need to select one?
Yeah. Yeah, see, it did it to all of them there. See, it's recreating them.
Okay.
So like on, say, J1, go click on it. See, it's not smart enough to not try to stick it on everything.
What was the baby ones? That was J1.
Yeah. Well, it was smart enough to do that one. But the other one, it didn't. It tried to add the pieces to it, if you noticed on like G1 or H1.
Got it. Okay.
But you can go in and fix that, go to the details on that truss and say, I only want it on one end. You could fix it.
Okay. So I would do edit basics, truss details, and I would say on the...
Right now it just says left, but you'd have to say both if you want it on both. That one made it only apply to the left.
Yeah.
On this one, you'd want to go.
Yeah, I had the wrong truss
basics. And then change it to right only. Because you only want it on the right side.
But don't I have to set the left to something else?
No, leave the left alone.
The left is messed up though.
The left, there's nothing going to be there. It stops at it's in the way of something else.
How do you get it to regenerate?
Well,
I thought I would have to remove it and put something on the left side.
Well, you can't mix and match. That's the problem. Well, you can. You'd have to say one's on the left and one's on the right.
Okay, yeah, look, that got rid of...
You can make it to none, yeah.
I made the left none and the right is fine.
Yeah.
Okay.
So you could do that too. But but that's how you're going to do it for that job there. You can add these details, get all the trusses in, go in and edit the detail for, and say, I want to apply it to all of them, and then fix the ones that have extra stuff.
Okay.
So works pretty nice.
These are the plates here?
These are the connector plates, and some of them are, the USJs are the
yeah, I see that up here.
Are those are connector plates. The USZs, I believe, are the what they call a girder plate that gets attached to the front of the truss with spacers to attach an oncoming truss to.
Oh. Let's see if we have any of those on like G1.
Yeah, yeah. Well, G1 is yeah. Well, not now because once you make a change to it, it takes the analysis away. So, of course, I don't know if you want to bring everything. So yeah, you have to analyze all the other trusses first
I see that.
because it knows, hey, there's loads coming into this because there's a loading file that gets created from the layout when it brings everything over to tell design, hey, I have truss A is connected, 3 feet from the left on truss. It tells it where they're connected at, so it knows where to put the loads at.
Okay. So I don't even need to use the edit menu because this looks like the edit menu right here.
Well, yes and no until you learn what everything does. There is a menu just for truss information, but not all of it's there. The loading, but there's no other way to get to there is another way to get to the loading. That's the fastest way to get to it.
But there's floor here, right?
That's for floor. That's different.
Floor
That's
is
floor
here
webbing.
and roof is here. Oh no.
No, that's just,
They just use the same symbol.
they have a generic, oh, it's not the same.
Yeah, there's 100 versus a question mark.
So loading, roof has a different symbol than floor does. But they didn't put, I don't know why we don't have a symbol for roof loading, but we don't. It's just
All
not
right.
on the toolbar. But anyhow,
What's next?
okay. So before you start doing anything else, we want to make sure that you can close this, hit cancel. So what we're going to do is we're going to go to the setup menu and go through all your what your default things are. So setup manufacturer, then go to basics because we're going to set this up and get this set the way you need it. So just say no. That's fine. All right. Don't worry so much about this screen here because that's going to change that's a job by job thing.
Okay.
All right. So you're going to go to design info first, the des info. Okay. So this is going to be default. So this is what you're going to start with. So you're
Okay.
in the upper right left-hand corner there. It's saying this is going to be your bracing up in the upper left. This is your bracing options. So right now it says top chord is sheathed, which means it's going to be, going to have sheathing on it. That's going to form the bracing for the top chord. And bottom chord is off as a default. And the bottom chord spacing, so the braces are going to be designed at least starting with 6 feet on center across the bottom of the truss. Okay.
Okay.
You guys may decide you want to do something different, but that's going to come up as a job by job problem too. If it's checked on, then the option for spacing goes away. If it's checked off, then you have to have a number in there. And it's, it just
So
depends on how they're going to put them up.
so this is basically like a furring every 2 feet. Is that how
Yeah.
you that's decimal
Yeah.
feet?
2
2.000.
feet. Yeah. So, okay, let's backtrack and start with that. The entry of distances and things in here, everything's in feet, inches, 16ths. So the two, and this one works backwards. So the two right numbers in any entry, two right numbers are reserved for 16ths. So if you enter 20/16ths, it will convert that to 1.25 inches automatically. Okay. The next two numbers to the right of that are reserved for inches. So if you have, and you always have to use the leading zeros in those. Okay,
So
you
like
can't leave them off.
this would be 6 foot, 11 inches, and 15/16.
Correct. So
That's a new one.
for inches and sixteenths, you have to use the leading zero for the numbers. Well, the thing of it is this has been the truss industry standard for 50 years.
Yeah, I've never seen this in my career.
It took a minute to learn it.
Good to know. What is EV sheath?
End vertical. If the end vertical, the truss is going to be sheathed, you can check that on.
So is that
If you don't know, you better leave it off.
Is that most applicable if you have a very large end vertical?
I would say so.
Like if the end of your vertical is basically a wall?
Well, if it's going to face the wall, I would just leave it off. But that's all end vertical, so that's not just, you can't pick left and right.
All right.
So if all your end verticals, it's kind of easier to leave it off.
You've convinced me.
And then, so the other thing about the note, anything to the left of the right 4 digits is feet, no matter what the number is.
Oh, okay. So you could have had this would
It could be 10,000 zero. You could put, if you put the number in 100,000, that's 1,000 feet, because it's 1,000 feet, 0 inches, and 0/16, but it looks like 100,000 because it's six decimals. I hope I got that right. No, it's a million. Never mind. But anyhow, the way you have it in there, that's 16 feet.
Got it.
And if you type anything with a decimal in it, that's a decimal feet is how this program works.
Oh, that's kind of handy.
So this is decimal feet, but AutoCAD's decimal inches. So you have to remember that. And you can't use the tick marks in here either. It'll probably crash on you. But you can make it show that way. There's some dimensioning options to make it look that way, but you can't enter it that way. Okay. Moving on here. This design options area, we have an optimization tool. I don't know. I've never ever found the point of optimizing stuff. I'll give you my reason for that, because I'm getting paid to do this. If I save $100 and spent 10 hours doing it, what do they save? Nothing. Probably costs more than that. You know what I'm saying? But that's my opinion. So I know people all swear by having to optimize stuff, but it's just,
so do you
I've always found it wasteful. But for steel's a different animal though than wood, so take that one.
Do you find that the trusses are most of the time fairly well optimized?
For the most part, yeah, but sometimes you can go in and see if you can remove stuff too. Like I said, I haven't been doing steel long enough to know all the tricks of what you can take out and leave in. So I inherited this position a year ago and didn't have a lot of time to learn it.
Do you teach everybody how to do wood as well?
Yep.
Oh man.
In a completely different program. This is learning what this does is it'd be like my 4th layout program I had to learn. But anyhow, 4th set of engineering stuff. The wood uses something real similar to this, but that's being phased out, doing something else. But okay, there's a couple tricks in that for the most part, you may not want to even mess with some of this stuff until you get so like girder plates, you can try and do full ones. I don't know how we sell them. And you can also do 12-inch, and you can tell it to do cycling between 12 and 24-inch, because what it does is it tries to put that length of piece attached to the truss to attach the truss incoming truss to it. So you may be able to manipulate this to try and get them to work, because they start overlapping each other. It'll tell you that it needs to be some special calculation needs to be done.
Okay.
Okay.
So should I leave it as 24 or change
I
it?
would leave it at 20. You can tell it to cycle if you want to. That's not a bad thing. It's one of those things. I don't think it's a wrong answer for any of it. It's more of a preference thing. The bracing material, that's our default bracing.
But I could switch it to, this is like more conventional stuff.
Yeah, go ahead. Yeah, if you know what you're going to be, if you know what's going to be used in your jobs, by all means change to it, because you know that part more than I would.
I'd have to look at it some more, but I think it's going to be something like this.
Okay. That's where you would change it, and you can say the bracing. You can change the length. Say, hey,
13 foot.
usually going to be in 16-foot lengths or whatever they're doing, 12 foot, and that's what's going to happen. Okay. Yeah. Yeah, you want to. We're working on getting the new IBC in. You're probably going to be 18. The other ones were Florida, the ones in between it. FBC, those are Florida codes, and they get real picky if you don't. They reject jobs if it doesn't say it on there. The next setting for steel continuity, what that means, you're going to get a less expensive truss if you tell it no continuity. Okay.
Right.
But if you're having too many errors, what it is that if you hit the drop down for that, it'll ask you, do you want the top chords the same and the bottom chords the same, which means that all the top chords, no matter where they are all going to be the same material, even if it doesn't need it. All the top chords have the same gauge and material width. Or you can make all the chords the same. So, but no continuity allows for it to be, well, on this side of the splice, I need a 16 gauge piece here, and I need an 18 gauge piece on this other side. So it could save you some money.
So it optimizes it, right?
What's that?
It allows it to be optimized to whatever size.
Yes, it allows you to, like I said, if you knew you were having a lot of problem with people putting their own stuff in, you may want to change that setting, but you're going to get better pricing with no continuity. Okay. Web bracing, those are the settings to start with. Default to lateral brace. And then you have options that say, I want to do a web brace before a lateral brace. And then you have a thing with a combination. So that would be whatever, that's what it starts at. And you can manually change each truss to do something different. Or you can even change each piece by piece if you need to, which will cover that. And then your 2-ply bracing options is set up for side C-stud, but you can tell if you want to put something between the plies too. Okay. So web design options, you can make it cycle based on, first worry about, do I need it braced, web size, and what you can tell it the order you want it to work on your cycling of the bracing. Try to put a brace on it, then change the size to see if it works. If it's not checked, nothing happens. But you can use that tool.
What is
Check.
that for?
So if you check the box, it'll start figuring out the web design based on those properties. Do I want to do things in a certain order to
What order does it currently use?
well, it just tries to figure out the lowest size and gauge material it can put in. But you can, if you turn that on, you can say, well, yeah, I want it to be braced first, but then, or you can say, I want to upsize first before you put a brace on it, type of thing. You know what I'm saying? You say
Okay, so
here,
you can change the
upsize.
order of priorities is basically what it allows you to do because it's already
Yeah.
optimizing it.
Yeah, but you can change the order of priority of how it picks the size of the web.
Okay.
You know, that might be something you guys tinker with a little bit on a trust by trust basis to
Sure.
test it out. Deflection. So you're going to have, right now it's set, this is the live loads area, and then there's a total loads in the drop down. Change to the total load deflection. Okay. Now, one thing to note, floor trusses have their own setting. That's different. This truss setting up here is only for a roof truss. Floor truss has its own option.
Is there any reason we need to change this?
At the moment, no, but you'll get more, and mostly it'll be like a floor job. Say, hey, we want you to run we want all our trusses to run L over 480.
Right.
Then you would go down to the floor truss area and change that to 480.
Okay.
But usually roof trusses don't specify that kind of thing.
And people don't care so much for the roof trusses.
Right. Unless they're doing something where they got one of these flat roof things they're use as a gathering area type of thing. I'm
That's
talking
a
about.
floor truss. That's a floor truss still.
Oh, well, yeah, but you got to apply roof load to it. If it's on the roof, you have to apply a roof load to it, because you can't apply, unless we did something in here that I'm forgetting. Or no, you can't apply wind load to a floor truss.
Gotcha.
But anyhow, but that's where you would change if the EOR specifies a deflection because he wants to get the bounce out of the roof, or or out of the floor. That's where you change it at.
Got it.
Okay, go ahead and click OK, because we're going through this and setting your defaults is what we're doing.
Is real quick, is the heel stiffener the plates?
Yeah. Well, it's not the plate. It's another piece that gets screwed on. You can tell that you don't want it unless you have this other options.
Okay.
All right. So loading. All right. So this is where you're going to set up whether you're going to design for over in the left-hand side, you're probably going to want to check on design for wind. Then you'll click that button. It automatically sets the loading standard. And then you guys understand what combined means, right? It's a combination of components of cladding and main wind force resistance. As a default, I would just kind of leave it at that, unless somebody says, hey, I want this CC, you know.
What is CNC?
Components and cladding, it's stricter.
Hmm.
And then your risk categories and exposure categories.
I actually have a project. Let's I have a project that we were looking at. Let me pull up.
Yeah, no, this is the boring part of the software.
Well, it's interesting. So let's just try to model it based off of their actual specs.
Right. All right, so that is
roof trusses, vertical deflection of L of 1/360 of the span.
Right, which is okay. So you'll have to change that.
Okay, so wind speed is 150 here.
Yep. And this one's using, that particular one's using IBC 2015 also.
Oh, okay.
But you can fix that. Now your risk category is, you understand what those are?
That's dependent on the type of building, right?
Correct. Yep. Okay.
More
than likely that school will probably be a 3 or 4.
Yeah.
It depends on if they want it to be a shelter or not, probably. Just to guess.
I can look into that, but 3 is probably fine for now.
Yeah. Okay. Exposure category, unless it's on the water, you don't want it to be D. C is probably a better thing. If it's going to be out in a field or something, C is probably your option. There's not going to be a lot of other buildings around it.
Yeah, I mean it is in a school complex, so there's like a bunch of other buildings around it.
Yeah, but I mean, I guess the question is how close are they? But that just gives you, this would be like, because right now we're just setting your default, so.
Right. Yeah, like
oh, this one would probably be, B would probably work for it because there's all the other ones that are right next to it.
Yeah, but we
help shelter it.
We
but
could
C is, you're kind of hedging your bets with C because if it's on the outside and everything's, you know, if there's nothing around the one end of it, you may want to go with C.
Mm-hmm. Yeah, there's nothing on this side of it.
Yeah, so C is probably a good idea.
Okay, but that's something we could ask the architects about, right?
Exactly, yes. Or the EOR, depending on who's specifying it.
Yeah, in fact, they might have that somewhere in their specs.
Yeah. Okay. So also in here, so you have these, most of the stuff, unless they specify it, I would just leave it alone.
Yeah. I think the rest, I didn't see anything about
building width. And now there's some other things. If you had cantilevers, you would check the boxes over here on a job by job basis, because you'll have to go to job properties to do that. But as a default, you can leave them off and then turn them on as necessary. Okay. Now,
real quick, where would I change that on a job?
Oh, click OK. Click OK. Set up job.
Oh, okay. So it has all the same settings. No, it doesn't.
No, it doesn't. It has a lot of them.
That would be too convenient.
Well,
you don't need to change most.
Some of them are pretty much set up for the how to explain that. There are some things that no matter what job it is, they automatically apply to everything. They don't give you the ability to change them job by job.
Right.
So, but anyhow,
So I went over here.
Uh-huh.
And it still didn't change this
it won't change that. You have to do that yourself.
on every single job.
On every job. Okay, so we changed the manufacturer settings. It doesn't apply to any job that's already started.
Oh,
What it does, once you save it, any new job will take those settings and pull them in. But
Got it.
any existing job has to be changed on their own.
Got it. Okay.
You click
Okay.
OK, click on loading again. Because as soon as you change the building code, it turns all of it off. Just giving you a heads up.
Oh, okay. That's why this was reset, because I was looking at it before and it wasn't changed.
Yeah.
Or it was
So if you ever change the building code off the job properties, all the check boxes for wind, snow, and all that get unchecked. Just a heads up.
got it. Okay.
So this is where you would change all that. In the middle is your standard load, top chord load, live, snow roof. You have snow ground too, but that would be set up in the design for snow. But you guys are in the area that doesn't get much, so you probably don't need to snow load it.
That is
If
correct.
you're staying in your area, if you're going north, well, then you'd have to worry about that. This is also where you would set, somebody sets moving point loads or drag loads. And if you get to one of those, just call me and I can walk you through it. Just to,
Moving point loads. Is that like for a roller coaster?
no, that would be for, moving partition walls.
Oh.
That's an example.
So that's mostly on the bottom chord.
Yeah. Well, you can do it on either, but you can do it on both. But you're only allowed to put one load in. Then you have your drag load down there, and you'll have to convert it to PLF to enter it if they give you a total.
What's a drag load?
It's a rotational load. They'll specify stuff like, it's more, well, there'll be shear walls and things in buildings that require drag loads on them for design that I don't know why they do them. I'll put it that way. That's an engineer question.
So in this spec, they said the roof loads are a minimum of 12 pounds per square foot.
Is that live or dead?
I think that's their dead load.
Oh, I just say dead, yeah. So you put dead load at 12 pounds. Yeah.
Okay, so we would change that.
Yeah.
Oh, interesting.
Now that, if you click on it, if you knew what that gives you the ability to say, hey, we're going to use these materials, and it would give you a dead load from that. If they don't call it out, you could go through it, and it pulls the information. We entered it based on the ASCE book that gets distributed. That tells you what the weight of things are.
Right.
Generally, if you want to calculate it, you can click on a bunch of stuff. You can hit calculate, and it'll tell you what the load is.
Okay.
If you click OK, it'll apply it.
Right. That makes
more
sense.
likely they're just going to tell you what they want.
Yeah, okay, so that's 12. And bottom chord ceilings and collateral loads are a minimum of 5 pounds per square foot.
Right, so you would change the bottom chord loading to 5.
Oh, AC unit.
Yeah, but if you had
A rooftop unit.
rooftop units, or if they were hiding it in the truss,
Like in the attic.
in the attic area, yeah.
Then you got a bottom chord or internal chord.
Yeah, you can tell it where to put it at and how wide is it,
Now,
all
wouldn't
that
that
stuff.
be specific to just a few trusses? And not-
Yes, that would be something you would do on only specific trusses. You don't want to put it on all of them.
Right. Okay, so you probably wouldn't even apply this in the job, right?
No, unless you're doing something small.
Right.
Hey, we're doing this addition. We're putting all the AC unit could go anywhere in the building. You're doing all the same truss, so you would apply it to all of them, just for simplicity's sake. And then you have this uninhabitable attic load. What that is kind of like the old in residential use. It's do you think they're going to stick stuff in the ceiling? That's what that's for.
Yep, we've seen it before.
So if you turn it on, it's going to put a concurrent 10 pound per square foot bottom chord live load, which means it's going to apply an extra 10 pounds to your
Yep.
standard load. And then the limited storage is 10 pounds only in areas that have a 42-inch clearance from the top of the bottom chord till it hits something.
And that's 10 pounds?
It's putting 10 PSF. Yep. You
Okay.
can change the number if you want, but
Yeah, I guess I was just curious what's the difference between these two?
well, one puts it everywhere. The top one puts it across the whole thing, and the other one only adds more in the limited. So you can make not the concurrent 0 and only put it. Oh, never mind. It has to be 10. Okay. My bad.
Okay.
You probably have to have that set to 10 too. It's picky.
All right. Got it.
So yeah. So if you don't want to apply it, you can check it on or check it off as necessary.
Got it.
Okay. But we don't have a whole lot of options at truss. Common is probably the best thing to just leave it at. Steel. This is what you're going to start. This is the starting point for all the trusses when they're created.
Okay, so it's starting at the minimum.
It's starting at the minimum, and then it'll get larger as necessary. But on a truss by truss basis, you can go in and say, I want to fix the size of this, my bottom chord. Don't make it larger. Because sometimes it starts to cause problems if it needs to be too thick. Because your heel height is kind of shallow. One of those things.
Got it. And webs and material product line.
And then you have some, so if you wanted to change your product line from USC to USD, you'll do it on a truss by truss basis more than likely. And then we have more options, gives you those other 5 types, structural and non-structural types. And it tells you what list to start on. We have some predetermined lists of materials built in.
Right. Is there a huge reason to be changing a lot of this?
No, not really.
I can see this being useful, but
That you'll do a lot of.
Yeah.
That you'll do most of, but the rest of it, you just have to be. I have seen it get screwed up before, so only like once. So So if you just use the switch, you should be fine.
Got it.
Okay.
So that's steel.
Steel, bearing material. What's your default bearing material? But
Other.
if you would leave it alone, Steel Engine's going to tell the program what it is. That's why you choose the wall type. It exports that information over
Oh.
when it brings the truss over. So if you set the walls at the right type, the right kind of bearing side will come over.
And it'll determine like the connection type based off of that.
Well, most everything is going to be there's going to be some kind of clip attached to it to
Got it.
screw down to whatever the wall is, or
Well, what effect does this have?
say that again, please.
What effect would this have on your model? This is what kind of wall it's resting on?
Yeah. That's what the wall it's setting on.
So what does the bearing material, how does that affect the truss itself?
Not particularly much, but it gives you different symbols. Some building inspectors are buttheads and expect to see things a certain way. I say buttheads because I'm trying to be nice.
Yeah. I'm sorry, moment. I'm getting a call.
Yeah, go ahead.
1 second.
Don't worry, we're almost over with the boring stuff.
All right, sorry, I'm back.
Okay.
All right. So I don't need to change that.
You don't really need to change that, no, because it's going to come over.
And we saw this
If
already.
you have a default detail you want to assign to stuff, and then the fasteners, that's the other one that we have. We start with some generics, but then we have some product in here. You know what screws you may be using?
Yeah, we have either number 10 or number 12, some variation of those.
Okay. We do have some manufacturers if you scroll down. So like we have Buildex, Senko, Pro Twist, and Grabbers, I believe, in there. So
Yeah, we don't use those guys. We use a different group.
okay, no problem. You can leave it at the generic one then. That's the worst case. So
What is the? I'm not familiar with the T/3. Maybe I can just look it up.
I think it's a grade, if I'm not mistaken. I think that's because screws and bolts have, well, I remember bolts were like cap was the name, was the, like cap 8s and cap 10s were the stronger types of bolts that have more shear capacity. If I remember correctly from working in a machine shop. I can't remember what the T/3 means. I think it has to do with the grade, but don't hold me to that one.
All right, that's fine.
Because I know number 1016, that's the size of the screw and how many threads per inch.
Yeah.
Okay. All right. So under manufacturer basics, we just kind of went through all that. Oh, yeah, the details and manufacturer basics doesn't like letting you pick one.
Okay.
That's usually a job by job thing.
Okay.
So under setup, you also have some other options about, like we showed the floor webbing pattern. We have company info you can put in. Can't remember where that shows up at.
Okay. That's fine. We can worry about that later.
Yeah. And then your options for like gables and fillers are down there. how do you want it the webbing to be put in? Regular, because you can do it on a truss by truss basis too, to change it if it had to be structural. This would be like what you do the most of. And if you had, that's for openings.
We can play around with this, but
Yeah.
are these
Yeah.
settings pretty good?
Yeah. Yeah, these are pretty good. I just wanted to show you where they're at so you guys can poke around and, well, we want all our studs 16-inch on center. That's where you change it at.
Okay. So a lot of these settings are the same that we were looking at already.
Yeah, some of them are, yeah. Yeah, we were just in this yesterday, so.
Yeah.
Okay. All right. And some of these under there, all these other ones that you see how, except for floor webbing, they're under basics also, but they have a tab so you don't have to go to click basics, then go, if you want to go right to them, you can just go to them and do them. That's what they're there for. All right. Moving on.
Okay.
Analyze, it's going to analyze truss. Yeah, everything's set to square inch. You can, if you want to make all your webs at 1/2 inch increments, you can check that box. If you're not worried about it, you can just leave it off.
Okay.
Yeah, don't worry so much about the analyze button. Tools are going to give you what's listed in the truss tools.
Okay, that's this menu over here.
Right. Which will be helpful until you learn what the buttons are. This will go, what is that button again? Oh, there it is. It'll help you get familiar better.
Oh, with the term, it has words.
Because it tells you what the name of the tool is.
Yeah.
But we can't. None of these work until we put a truss on the screen either. So, and then you have view. What do you want to see on the screen? Okay. Now, what you turn on here will print on the drawings. So, like if you turn the analog line on, it's going to print. If you go down and turn on, now one thing you will want to have on when you go to print is the screw count. Because when you analyze it, it's going to put a little circle where the you don't want to turn those on to print. That will make a mess. Another thing that gives you a little more visual, if you turn the screw area on for just a minute. So you got to analyze the truss. So
How do I analyze it again?
The button that looks like a stoplight. Oh, pick a different truss. There you go. Okay. So just so you see what all this stuff does. See these little squares on each piece? That is where the web contacts the face of the core.
Oh, so that's a valid screw area.
That's where that's the area that you're going to be able to screw into. Okay. That's the valid area that you're going to be able to put screws in. So it kind of gives you a visual because that's where it bends towards the back end and comes back.
Right.
So there's two flat areas that you can put screws in.
You don't want to screw right in that middle area because there's
you can't, yeah, because the screws won't be long enough. So it gives you, the designer, a little bit of, so you can see it.
That screw count is pretty handy.
Right, the screw count's there, so you want to have that on when you print, because that'll print on the drawing. Then they know, okay, for this web I got to put 2 screws in. This web I got to put 2 screws in. You know.
Got it.
All right. But if things get in your way, you can turn it off.
Okay.
And any toolbar you don't plan on using, you can turn off too. So, all right. So, and then the save button is right next to it. So, well, hang on, before you hit save, I'll show you what that does. Go ahead and, yeah, go ahead and do that again. That's fine. So in here, when you're looking at this, over here on the left, it says 1 of 16. That's the load case numbers. Okay.
Load case.
There's 16 load cases on this truss.
Oh, so you
It
can
tells
see
you what the load case is up here too. So load case 11 is dead load plus 3/4 of the live roof plus 3/4 of the live right bottom cord plus 0.75 times it's I think it's a wind is what this is for. But then it tells you what the CSI, you guys know what CSI is?
Is that like this? No, I don't know what that is.
It's the combined stress index.
Got it.
So you look in here and down in the lower part of this, right here it tells you the max, what's the maximum on the top cord, bottom cord in a web. It doesn't tell you which one it is, but that's the maximum number. You don't want any number over 1.0. Okay. Then it tells you how much the price of the truss is based on the pricing that's in here with
Over
mostly
1.0
material.
is failure, right?
What's that?
Over 1.0 is failure.
Yeah. But that tells you how much it costs based on your material price and any labor factors you have to work out. So that's another thing you guys are going to have to think about is how do you want to calculate labor unless you want to do it manually.
How do they? I'm meaning to ask this. How do you recommend calculating labor?
That is a loaded question. Well, mainly because I don't know two people who do it the same.
Do you have any recommendations or rule of thumbs?
Not really. Some people want to do a square foot price. Some people want to do, a lineal foot truss price. Say, well, never, and then some people have to sit there and think about how they want to do it. Now you may want to pick Kevin's brain on that one, the salesperson, just
Right.
because steel calculations and it's different. He may know that, okay, most everybody does, well, in wood, a lot of people do board foot prices. So they calculate how many board footage are in a truss and say, I want to charge $3 per and move on, which I don't know how much money they make off of that. But in this case, steel, you can't really do that because you can because it has a way to do it because it had to convert from in the wood when they turned this into a steel program. But there's lots of ways you could say, you can put manufacturing labor in. You'd say, well, here, we're just going to put in for labor. It takes 3 minutes to put a screw in. Put that in as a factor and move on too. I don't know. That's your biggest labor is putting screws in.
And cutting, if there's cutting.
The cutting too. Yeah, I know that. Then you can set it up for that too. Depends on if you're going to order stuff.
Okay.
We will pre-cut stuff too, but I don't know all the restrictions on that.
All right, we'll get with Ken on that.
Yeah. And
where do we
once you
those
figure out what you want
factors?
to do, call
Mhm.
me and we'll set it up.
Where just out of curiosity, where do we go to change those settings?
You mean the labor settings?
The labor and the material pricing settings.
Oh, okay. Well, the material pricing settings are in setup manufacturer. That they're both all in there. And then you're going to go down to steel inventory. Estimating is for labor. Steel inventory is material cost. Okay. And then you're going to go through and say, you're going to go to over here to cost groups. Pick a material. And that's
Okay.
price per 1,000 feet of it.
Yeah.
You can do a plot, you can do a percentage upgrade, or you can go through and just change the number.
So we have to update it all manually.
Yeah.
So most likely we'd probably generate the trusses and figure out what profiles we're actually using, and then we'll go price it out and get the
Right.
price.
Well, I think you may want to put in this is the price without the discount in it right now. That's our current price for that material.
Are
We
these
put that in.
are these numbers live?
Yeah.
Like they'll change automatically?
No. Oh, that live. No, they're not that. I think if we ever have changes, I've heard that the last time they had a change, we sent a file out to everybody to update it.
Well, that's nice.
But that's been a while. Um, in the wood world, they have to do it themselves. But we don't provide the material, so that's different animal there. But if so you would just change the number and click OK. If
Yeah.
you want to limit your material lengths, you can click on that and change the lengths.
Say that again?
Right now, you have stock lengths turned on of 1 to 40 feet in every 1 foot increment.
Where do
And the
you,
reason is to give you better prices because we sell it in 40-foot lengths.
where is that setting on?
Oh, go back to cost groups. Pick one. Click on inventory length.
Oh.
They're all on. So just so you're aware, if you turn some of the lower ones off, what'll happen is that it'll find out, okay, this piece is 20 foot long. If you're only had 40 feet on, it would charge you for a 40-foot piece for every one of them. It doesn't know to combine stuff. It's pretty simple.
Okay, so keep it like this?
I would, unless you want to go, well, we don't want it. We want splices on. Well, we can change the splice setting here. That's a different place.
Yeah, I saw that.
Yeah. So if you want to keep right now it's set to 40 feet. Yeah,
It is?
splicing down there. You're not allowed to change the middle part. All you can do is say, I want my preferred splice length to be this, and I don't want any splice piece less than 6 right now. It's going to automatically, if anything over 40 feet, it's going to put a splice in it. And then it's going to go, well, the shortest piece I can splice is 6 feet. So it'll probably put a piece that's 6 feet in, and then the rest of it will be the rest of the truss.
Okay, so like if it's 41 feet, then it'll do 35 feet and 6 feet.
Yeah. Roughly. Yeah.
Unless it chooses to like do something in between that. But the minimum will be 6 feet.
Yeah. Now sometimes you got to move them because they get in the way. So You don't want splices at webbing or, you know,
But all of these are checked, so it will just optimize for the foot length.
right. So you'll get the closest foot price when it does it. So you'll get a better pricing having them all on.
Okay. All right.
Okay. All right. Now this is where you have to go in and you have to create. Now you have to have one for each type of product too. Because you can say, well, because USD is heavier or wider. So it's actually, each piece is going to weigh more. The question is, how do you want to do your calculations of your, you know, we have lots of options.
All right. Well, let's get into that later.
Yeah, you can get on it. Yeah, I just wanted to show you where it was at since you asked.
Yeah. I want
Otherwise, I would have just left it be. All right. So let's bring up a truss now. All right. I'll bring up the one we don't have to. Well, yeah, you did. You're good. Okay. So we'll go into the, so the edit toolbar, going into the toolbars here real quick. The edit toolbar has same things that are under the edit, or not edit, the file toolbar. Sorry, wrong one. So file has all these options. They're on that toolbar that's directly below that.
right here.
Yeah. Okay. The edit toolbar, yeah, you probably don't want to have it by itself, but that's up to you. I mean, you can drag it to the other side if you want, whatever you want. But I would, because what happens if you leave them in there, they get in your way. Because it'll go over top of all your stuff if they're not docked. So the next one is technically the edit toolbar, which is how you get to all the information about a truss, the truss on the screen. So if you wanted to change from USC to USD, you could click on steel, change the product line, click OK, and then go from there. It goes back to the minimums, and then you reanalyze it, and then it doesn't change your geometry, it just changes the metal that's in it.
Right.
If you wanted to change the truss detail, you'd come in here and do it that way. Floor webbing isn't going to do anything to this truss. Neither of these two do anything to a roof truss. Okay.
All right.
The next one is the job. It's anything that would be under setup job. So instead of go setup job, you have this toolbar here to go job basics, job design info, job steel, and then you can apply a global change to everything. So the buttons there, you can just grab it. Okay. Next one we have, this is the analyze toolbar analysis. It automatically starts at the beginning and puts it all in. Upgrades what's need to be upgraded.
How
Okay.
how do you pull up the analysis to do the analysis on all of them?
Oh, well, there's a couple ways to do that. You can go file batch and bring it up. Go ahead and close that. I'll show you another way to get to it. Go down to the bottom in the truss list, right click, click on the name, the truss, put a batch there. So there's a couple ways to get to it.
Got it. All right. Sorry, you were going through all of these?
I'm just kind of going, yeah, I was just kind of glossing over the other ones real quick. Okay, so edit bearing. If you click on that, go ahead and move. It automatically selects the left bearing to start with. Okay, but it put it over top. If you hit the, click on the, grab the, yeah, it'll highlight it in red. That's the bearing that you would edit. You would click modify, and then you can change the width, type, and so another thing to look at, you see type in the name over here. Type pinned, and then type roll, H roller. All right. You have multiple kinds of bearings based on how to figure out deflection. So as a default, the left bearing is always pinned, and the right bearing and any other bearings along the bottom are what they call H rollers. So imagine instead of having something solid to sit on there, it's got a roller sitting there. And when all the weight comes down, it can just extend out. So what it does is it uses that to figure out how much horizontal deflection is in this truss.
Right.
There are some cases you got to use something called a V roller, but that's has to do with like Mansards and stuff. And then one thing to say, you can't use pinned.
It won't solve.
Right. Because yeah, that standard got changed about 25 years ago.
That's a statics problem.
Right. Well, old programs used to let you do it. So designers would trick the program and do that to it to get trusses to work. And then they had to go, then the truss the software people, no, you can't do it. And engineers had to put their foot down and put errors in so people would stop doing it. I know this because I know designers who did that. Well, I just made it pin. Like, that's not right. You know. So. Also, you have what side of the bear, what it has distance to bearing. Everything is well, most everything, it says right now, edge of truss to measure from. It's measuring from the left. Okay. So the left end of the truss, and the left end doesn't count the overhang usually, unless it's a cantilever. All right. So you can turn the bearing into different types too, but that's how you determine where the bearing goes. It's like the side of the bearing. Well, here's the bearing. It's 30 feet from the left. All right. What side of the bearing am I putting this on? Is it the center of it? Is it the right side or the left side? So you have those options to manipulate it. Okay. And if you want to remove it, you would have it highlighted and hit remove. And then you can just close the tool. Okay.
Got it.
All right. Bracing. The next one has to do with bracing, but you would pick a piece and then you would uncheck the box for use the design info bracing settings and make it different based on what needed to be done.
Do you see people use this very much?
Yes. Because if you have, like on your hip trusses you have on the one end, each truss is different. So anything that has a shows a hat channel on it is going to have to be, each web that has is going to have its own brace on it, because steel engine will flag it when it calculates bracing.
So you have to go change that?
Well, first you wait to find out what bracing it calls out.
Or
like this one, there's 20 of them. You don't have to worry about that. It'd be more of a something else.
you said on the
when you do calculate bracing, so like H1, H2, and HG1, those, if they call out hat channel, you're going to have to manually brace those webs. But until you analyze it, and there's only one, so and there's no brace on it, so you don't have to worry about it.
Okay. Oh, you're saying like the bracing wouldn't work. So you
Right,
might have
because
to
there's no
remove it?
truss you can't
There-
brace it back to anything.
Yeah. I see what you're saying. So it's handy for modifying the bracing. Okay, yeah, that's what it
Yeah.
says.
It's just for modifying the web braces. That
All
one is if you want to add a cantilever to a truss. You're going to have that set up out of steel engine, so more likely you're never going to use that. Unless somebody called you and said, hey, we're going to build this 300 by 75-foot building, and all the trusses are the same. Can you give me a quote? You could design a truss. You can design, 50, 75-foot trusses with a cantilever on them. But that's the only tool to put a cantilever on a truss because Truss Basics doesn't allow you to do it.
Okay.
The next tool has to do with adding dimensions. If you want to add a dimension to a truss, say you wanted to call something out specifically, you could do it. But now you'll have to look, see what kind of dimension you're adding. Right now it says horizontal. You can also use that to measure stuff too. If you want to measure exactly from point to point, you'll set it to rake. And then if you want a vertical, you'll do vertical and horizontal. And as long as you don't click on the screen, it won't put it on the screen. You can click try again. And it'll erase the thing and start
Okay.
over.
So it takes 3 clicks.
Yeah.
2 points.
Yeah. 2 points and the where do you want to put the dimension at?
Got it.
Okay. If you wanted to turn the truss into a gable end, that's the tool to do it in. And is it exposed to the wind in the front? You turn that on. What the heck happened there?
I turned it into a gable end.
No, I know that. Why did it lose the overhangs?
Oh.
Interesting. All right. What
Ungable.
if it just doesn't like the?
Yikes.
Yeah. Well, just don't. It won't do. It'll crash if you. Hang on.
All right, we're good.
So pick a different truss and then come back to that one.
Aha.
K-Web, if you have this tall vertical, it needs to be stabilized on either end. You can do the K-Web tool. And it just says, what vertical do you want to do? But you have to have another vertical on either side of it to K-Web from. And it goes from that vertical, it puts diagonal webs up to, right now it's default to mid height, so it'll pick the piece you start with, you tell it to K-Web 2. So, okay, let's do it this way. Pick internal web, and then click OK. It's going to ask you to pick an internal web. No.
Oh, okay.
It's down in the command line. It's asking you what to do. It's telling you what it wants to do. So you would pick that, pick an adjacent vertical web, and it'll put webs like that in there to stabilize that vertical. More than likely, you do that kind of stuff on maybe some monos, step trusses, things like that.
So if you see something failing, that's when you go mess around with that?
Yeah, usually. All right. Leg down, if you had to if the bearing had to be lowered, you can add a web that goes down to the bearing. Okay. You would just tell it a negative number or a positive number to go down and a negative number to go up if you had like a raised beam. You got to pick a bearing or a location. And it would drop it, but yeah.
That's kind of cool.
There are some guidelines to make sure that you keep that stable and this truss doesn't get unstable. But lock material. If you don't want any of the material in the truss, say somebody said, hey, we need to add this extra load, but you've got all this designed. You can lock the material, add the load, and then analyze the truss to see if it changes or needs to change. If it passes, then you're good. If it fails, then you know you got to make changes to it. That's the only way to make it not change any piece. Well, that
Okay. So that'll lock all the pieces as it's shown.
as what they are currently, yeah. Your truss just flips it end for end.
Oh, does that mean I'm looking at it from the opposite direction?
No, it literally flips the truss.
Okay, so now all the members would be
That's
reversed.
it. Just yeah, you're going, but it's going to be manufactured the other direction.
Right. All right.
We're going to skip that one because I always found that this tool is useless. It's too arbitrary, and I recommend not even fooling with it.
Kind of fun. All right.
It's fun to mess around with, but you don't know where you're going to leave. You can't tell it where to leave it at by putting in a number and say, I want it at a certain point. We do have a tool that does that. It's just
Is
kind
this-
of
Is this nomenclature here? Is that feet, inches, 16?
16ths. Yep.
Got it.
Yeah, I find you're probably never going to use that. Just
Okay.
because there's something faster to do. All right. We're going to skip the next two real quick and just kind of do the other ones. We're going to go to the easy ones here. Reverse web. Click on it, pick a web, it flips it.
Whoa.
Now, some things you can't flip. Okay. Verticals you can't flip.
All right, that was pretty.
It's only for diagonal webs is what that's for. And I'll give you an explanation of how it does it. You know, because it has a boundary, like a big square that it fits in, and knows that it can't go outside that square. So that's how it turns around. It's based on the definition of the line that forms that piece. Now you may have to do some flipping because our material doesn't work all that great in compression sometimes. It's better in tension than compression.
So if
So
a
you may
member.
find a web fails, then you flip it and it works fine.
Gotcha. That's what I was curious. Okay.
Yeah. So you'll
All
use
right.
that a little bit. Reinforcing member scab, that's for adding a scab to a piece if it's failing a little bit. You can say, I want to put a scab on there that's screwed on to basically make this area stronger. So you would click, we only sell this in like 8-foot lengths from what I understand. You would click new, tell it where you want to put it at, and then it puts it on, one side or the other.
But I
You know,
might
it's,
want to do a 4 foot or something, right?
yeah. Uh-huh.
And will
You
it
can also,
analyze it with that in there?
oh yeah, it'll analyze that screwed to the face of it.
Perfect.
More likely you're going to do this on a cord than a web, but
Got it.
okay.
So maybe something like this.
Now this is, yeah, something a little bit, yeah. So if you got to get the cord, it'll analyze it with it up there.
Okay.
All right. There. We're gonna skip that one too for a minute because that thing is the most complicated tool we have. I'll come back to that one. Special loads. This is how you add extra loading to the truss. Okay. So based on whatever you got to do, you would click on new load, and you're going to tell it for manual loading. Sorry, not new load. And then you're going to tell it how to calculate this. So all load combos means it would try to put it in every load combination. Now, if it's specific, you can change calculate to user defined. Okay. And then in user defined, now you got some more options. Now your distribution is always going to be concentrated, trapezoidal, or there's more above that. Those are the ones you're more likely going to do stuff with, but you have 3 kinds of loads. Concentrated is a point load. Uniform means the same load from point A to point B. And you guys know what trapezoidal means, right?
Yeah, it's not a continuous. It's
It grows or shrinks from
Yeah,
point A
like-
to point B.
yeah.
Okay. But with user defined, okay, so when user defines on, you get to choose what kind of load it is that you're adding. You can say it's live load, dead load, roof snow, ground snow, wind load. So if you hit the load type, you have options. Otherwise, it's just going to bring it in as a generic. So your load type. So you have your different options. All those, you can tell it what kind of load it is. Okay. And then the direction, unless you're in user defined, you can't change the direction either. So you have down, up, right. They're scrolling the list there. It's left. And then you get to these other ones. N up, N down, P right, P left. Okay. P right and left is parallel to the truss.
Okay.
N up and down is perpendicular to the cord you select. N means normal. It's an old term that they never got rid of. Now, and then the truss face, you can do front or back as well. So, location, the location is going to be based on, right now you're telling the location's at 6 feet based on, you have 3 options. You have entire cord, top or bottom, cord segment. So if you had multiple cords, you could pick the cord you want to use and then apply the load, and everything's measured from the left of that selection. Okay. And then panel means you could just pick a panel in the truss and put it in. All right. Now to add to load combinations, what happens is you can say all load combos, or if you were doing some kind of snow or wind, you could say if the load type exists, only add it then. Or if it contains the load type. So these will be helpful when you get into some special things you got to load, especially cupolas, towers, things like that are going to be like on top of, or solar panel. There we go. You mentioned solar panel.
Yeah, that's what I was trying to mimic right here.
You have to go in and say it's a, well, right now you got it as a point load. So to do point load, you have to calculate, okay, how many points is this going to touch someplace? And then, okay, how much does this weigh? Say it weighs 50 pounds, right? Just for example. It's attached across 3 trusses. So, and at 2 spots. So then you would take 50 pounds, divide by 6 points that it's going to be attached to, which will distribute the load. And then that's what you would enter it as the weight.
Right. Okay. So let's say on this one truss, I have it at 6 feet up or 6 feet across and 20 pounds.
Yeah. Right now you got it set on, it's going to load it on the bottom cord right now.
Wait,
You'd have to click on the top cord to change.
What? Oh, okay, there we go.
You have to click where you want, what part you want it added to.
Got it.
Okay. Questions about that, or you want to just, if you have to do it, you can. If you want to play with it, that's cool. If you get stuck, just let me know and I'll.
So this is the one I added, right?
Yeah. Yep. It's over here.
Yeah, let me just make it down.
Yeah, there you go.
Okay, why isn't it measure from distance 1? I tried to make it 6 feet. Or
Can't put the tick. Yeah. Yeah, hit enter.
okay, that's good. Okay, now I see it there. That makes
You
sense.
can edit it from there without having to go back into the interface.
All right, that looks good.
Right now, you're only editing this load combo. So if you want to edit it for all of them, you'll have to go back into
Modify load.
uncheck the box is what you have to do, is uncheck that box, then select it, double click on it. Okay. And then just click OK so it applies everywhere. Then if you switch load cases, it should show in everything else in the same spot. A lot of it depends on how you added it too. No, I didn't put it.
I might have to delete it, or oh, look, here it is. Update load. That
Yeah.
wasn't.
Make sure you don't click on update load cases. Yeah. If you told it to reset the load cases, all additional loads get removed.
Okay, but it didn't change it for all of them.
Right. Because you told me only to edit it for the load combo.
Okay, how do I edit it for all
Go
of
ahead
them?
and double click on it. Now, the fact that it says 12 means that load case reduced it. So go ahead and click OK. Now it's at, there you go. Because it's taking 75% of the load on this one. So switch to a different load case. No, I didn't edit it. Never mind. You're better off just removing it. Remove load. Yeah, but you had to, pick another one and tell it to remove it.
How do I remove it from all of them?
Don't click that. That removes the load case.
But how do I remove the load case for all of them?
Well, you have to pick the load. You have to make sure it doesn't say edit this load combo only.
Yeah, I don't have that checked.
Yeah. Well, and then you have to tell it to remove it. It's kind of picky.
Oh, okay. I think I got it. I just reset them all.
Yeah, reset does it too.
Okay. Okay. I think I can finagle it.
Okay. All right. That one is to select your splice, put a splice in,
Or you could modify a splice.
or you can modify a splice.
All right, that's probably the most useful use case.
You can just double click on it. Not that. Hang on. You should be able to click on the splice. Done that before. But yeah, click on it, and then you can just change it. Delete it, move it, however you want.
Got
You'd
it.
have to hit modify and then tell it to move.
Right. I get you. I get it.
The next part, yeah, we have, if you had a top core bearing, and just to let you know, this is basically set up for mostly for like flat trusses that are going to be sitting on a top core bearing and the bottom drops underneath.
Right.
That's how you would edit trusses like that. Say, hey, this is top core bearing, and it puts the, drops a vertical over and does some other things.
Yep.
And then the other one is to add reinforcing members to that top core bearing end. If you have other webs that drop down, it doesn't work very well. It only works real well if the top core is actually bearing on the wall or beam or whatever you have. If you have another bottom that's lowered, it'll only do like one side. It's not intended for that. It's only for strictly top core bearing right there. Okay. And don't worry about this valley thing. Basically, you're turning your truss into a valley. One of those tools you're not going to mess with. And these are some view things where you click on the screw areas or the analog.
Right.
Scale if you want to change the scale of your.
That's view. That's more view tools.
Yeah. And then you can change the font. Now, changing the font too much it'll affect what you print too. So.
All right. We made it.
Okay. Now, let's go back to the stuff we didn't do. I skipped the hard stuff. So we're going to go to that tool. Okay, so that one there. Okay, so you have two tools that look alike. Okay. The light blue one is the good one. The other one I've been told to not use because it never worked right when they put it in. So
always use profile?
use profile, not the other one. That's what the guy who trained me told. So, and he did this for 40 years, so I will take him at his word for that. All right, so yeah, click profile. Okay, so the profile tool has multiple functions in it. If you have a truss that starts doing weird stuff, you can come in here and just hit the build button. It will reset the truss. Okay, which means that it resets it. It could fix your problem. Okay. Another function of this is to manipulate the webbing and panel points. Okay. So if you click in there and bring one up, that, okay. Actually, that didn't turn out as bad as I thought it was going to turn out.
So that
Unless you hit build, okay, so hang on, let's go through what this does. Yeah, unless you hit the build button, it's going to screw up on you.
Okay, so you always have to hit build to go back to the view.
Well, okay, so build basically takes the information that's right on your screen there and recreates the truss. If you hit cancel, it'll just go back to what it was. But this is in here. Yeah.
It
If
doesn't
you
do
double
anything.
click on it again, it'll just come back up. All right.
Oh,
So a couple things you're not going to want to do in here. You're not going to want to use backup or clear, because backup starts taking pieces out of it and clear erases it. Okay. So let me go through what all this does. So say you want to add stuff. You would select a chord segment. On the left-hand column, it says add joint, add JT. It does it equally unless something's locked in, all right? If you want two joints to line up with each other, you can grab one, left click and hold it, drag your mouse to the joint you want to line it up with, and then let go.
like
And
that?
it'll line up with that. And then that means what happens is that it locks it in place. If you hit unlock all, it'll unlock all those joints. They'll still be floating then.
All right.
Okay. So if you find you need to add webbing, you're going to want to come in here. Where do you think you need to add web at? Okay, pick the section you want to add it in. Pick a different truss here. Just hit cancel. Pick on T2. I want to show you what tools you have for symmetrical trusses. So wherever you need to add stuff, do it on the left first.
Okay.
So hit add joint.
And then I can mirror it to the other
Then
side.
add it on the bottom. Say anything you wanted to add to the bottom. And then hit mirror. It'll duplicate it on the other side of the truss.
Got it.
Okay. So add remove joint. You also can pick a spot and just type in where it goes. You tell it to optimize, then it's going to try to. And it doesn't mirror right to left. It only mirrors left to right. So you could unlock them. I'm not sure what the optima. I wouldn't. For me, like I said, the optimize tool seems like it's a little. It's thinking for you, and I don't know why it changed things. It did, but it does lock stuff in. See, now you gotta hit cancel.
Okay.
Say.
So let's add a joint here, and we'll add one down here, and we'll mirror it.
Yeah.
And
If you hit build, What it looks like. Excuse
All right.
me. Okay. If it's not putting the webs in the way you want them, okay. It has right now when you go to before you hit build, there's an auto web turned on. See where it's right there where your mouse was right in the middle at the bottom? You could uncheck that, click the build button, then it's going to force you to string where the webs go by clicking it on each end of where you want a web to be at.
Okay.
And then you have to click build again to finish it.
Okay, that's really helpful because we had like a customer who wanted this clear space on the inside of their truss for
Yeah.
storage.
And then you'd have to turn that non-habitable attic setting on to do that,
Right.
to make sure that you got enough load in there. Okay. Yeah, it's not, we don't have any way to make it do that automatically, but you can come in and you see how you force it in there.
Right, right. And they
Moving
only
the joints
cared
around.
they only cared for the majority of their trusses. They didn't care about the recesses of the attic. So
Well, yeah. Some of it's, you have to, like, it's impossible to do it everywhere.
So can I actually change the shape of this bottom cord? Like could I make it that V shape?
You can. I don't recommend doing it in here. I'd recommend doing it from Steel Engine.
Got it.
Okay. Will had a request since G1 was failing, how do we modify that to make it work? He was in the chat window here. So what we need to do is run batch on everything first. Add all and then run batch. I guess the question is, did everybody do this to their stuff? So click OK. Then it'll finish. Once everything lights back up, then it's done. So on this particular truss, the first thing you're going to want to do is change the material to USD. Start with that. Product line, yes. And then go ahead and get rid of the, and that's all you needed to do to fix that truss was make it USD instead of USC. Oh no, it still failed. What's going on? Hold on. Why did that fail? Go ahead and get rid of the extra, that detail we were messing around with.
This one?
Yeah. See if you can you have to get rid of all of them.
On all of them?
Because we didn't really do it that way to start with. So just on this one, that's all we need. All right. Click OK. Why is it still hit save? That's why it's still X. Yeah, there we go. Okay.
Oh, it passed? How did you know it passed?
There weren't any bright red pieces anywhere.
So this maroon color is
That
passed?
is 12 gauge.
Oh. Oh,
Dark
it
maroon
passes
color
though.
is 12. bright red is failure. I
Passes the-
question why, but I don't know, somebody made the choice that the 12 gauge has that dark red is the color they spray paint the ends of it.
Dang.
So you have to hit save to save the truss. This one was a pretty easy one. So now, just to show you, see all these little pieces out here on the bottom cord?
Yeah.
So what that represents, there's going to be like 3 spacer pieces that's attached to the face of the truss, which are, I can't remember what they call them. But once you have them done, yeah, you can tell it to import all of them. Hold on, you got, oh, there it goes, okay. So now you'll see the 3D version of everything brought in.
So this girder truss here has all those connector plates,
Yeah, see
right?
how they're attached on there? Yeah.
And okay. Okay, so let's try something. Let's say that we want to make this a USC truss.
Okay. Go to basics for the truss. Go ahead and exit. I think we made this a 2-ply. It's already a 2-ply, so it's failing.
Oh, we did make it a 2-ply already? Was
I
it a
believe so.
Was it a 2-ply as a USD?
I don't know. Let's go back to truss basics. It'll tell us.
Truss
Go to edit.
basic?
Yeah. No, it's a 1-ply. You could try and change it to 2-ply.
Fine.
Change your minimum and maximum plies to 2-ply. There you go. Now go ahead and run it.
Oh, all right.
And that
So
might work too. Okay, so look at the. Okay, so reanalyze it. Tell it what the. Look at the price. Price is $935.
okay. So now let's go
Change it back to 1-ply in USD and see how much it was.
Oops.
How much was it? 954. Okay.
Interesting.
But you only have to build one of them.
Yeah, but it just depends. Like, if we're just buying 3 pieces of USD.
Right. So that's a choice you'll have to make. But that's how you're going to compare.
Right.
You're going to have to decide, well, do I want to make it 2-ply and worry about the installer having to do more work? Or do I make it a 1-ply? It may cost them $20 more, but it's less work on the installers may love you for only having one truss.
Yeah.
It's a balancing act, as you probably already know.
Yeah. Interesting. All right. And does this factor in waste whenever it gives you this price?
It looks at everything it's calculating what the stock lengths are. So it does have waste in it because,
But
that's
saying, say
like
this.
So
this
like,
part, go ahead.
go to, all right, so to show you how to print stuff, we're going to test that here. So click on print preview, just to the left, right of me, my other left, there. There's the engineering drawing, what they look like. If you scroll down further, you'll have to hit next page. That's the rest of the engineering. Yeah, just hit close, then it'll pop up the shop drawing. So if you go down, that tells you how long each piece is.
So T1 is the piece that upper.
Yeah, so T1
Oh.
is 15. So you're getting charged for a 16-foot piece or a
Right.
13-foot piece, but you're gonna have like an 1.5 inch waist.
Right, but also
But this is you're charging your customer this. If we cut that for you, we don't charge you for that as far as I know. I don't know. That's
Well,
Kevin about that.
I think there are some minimum order limits. Like if we
Right,
just
right.
needed one piece of USD, you probably would tell us a 40-foot length. But if we needed, 20 pieces or 30 pieces of it, then you might start cutting them.
Right,
to-
yeah, there is a quantity difference of each type and length. There's a minimum length and a minimum quantity. Those two are factored in
Right.
for shipping you what the actual pieces are, so you just have to put it together.
Is there any way to turn this sideways?
No. Well, maybe. Go to it never looks right, so that's why. So what you have to do is you got to change the report. Probably don't want to do your engineering drawing sideways.
Doesn't look too bad.
It just makes it real small when they go to print it.
Right.
And we won't, when we do seals, they won't be that way. Now, shop drawing sideways has some advantages because the truss will be bigger.
There's a way to make this bigger, right?
Yeah, you have to go in and you got to go into the settings for output